Now we are going to learn about refractive index and laws of refraction. For that, first shall we recap what we have done last week. This is the glass block used in that experiment, and that is incident ray and refracted ray. Normal drawn at the point of incidence and angle of incidence and angle of refraction. You can see two angles there, angle of incidence and angle of refraction. Do you think that there is a relationship between these two angles, angle of incidence and angle of refraction? One thing that you know is, if you increase the angle of incidence, angle of refraction also increased. So what is the relationship between these two? There should be. When this is increased, that is increased. There should be a relationship. How can you find this relationship? Do you think that when we double the angle of incidence, the angle of refraction also double? No, it does not happen. There is another very fine relationship between these two angles. How can you find that relationship? No, we do not want to find that relationship because it has been discovered by a big person we are going to talk about. Shall we? I'm going to focus the point of incidence. The point of incidence is the point at which the light bends when changing the medium. Now here in this example you can see light entering glass from there, and then it bends at the interface, making angle of incidence and then making angle of refraction inside glass. These two angles have a relationship. Shall we see what is the relationship? You just take the sine values of these angles. Sine value of I divided by sine value of R is a constant. I divided by R is not a constant, it has no meaning. If you take the sine values of angle of incidence and angle of refraction, and when you take the ratio between them, there is a relationship. That is, sine I divided by sine R is a constant for given media. Shall we see? This constant is called refractive index. Sine I divided by sine R is a constant, that is refractive index. But how do you write it? How do you explain it? Just see. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. What does it say? The ratio of, this is a ratio, you know that. Ratio of what? The sine of the angle of incidence. Ratio of sine of the angle of incidence to what? To the sine of the angle of refraction. It's a constant for what? For a given pair of media. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. Why do we say that for a given pair of media? Now, say, when you think about light entering from air to glass, this constant is 1.5. Any angle of refraction and any angle of incidence, when we take the sine values and when we take the proportion, when we take the ratio, it gives you 1.5 basically. There are different types of glasses, say perspex and so on. There are little differences, but generally it is 1.5. For glass, if you take sine I divided by sine R, you have the value 1.5. So that is what we call refractive index. But it has a sort of symbol. Constant is K for everything, you know, right? We use K for any constant, but here the constant is given a specific symbol, that is nu. So sine I divided by sine R is nu, simple N. When we going beyond that, if I say, oh, refractive index is 1.5, then you would think refractive index basically is for the given pair of media, then from which media to which media light is going. So therefore in this we have to mention the two media. So therefore when light going from air to water, what we do is we use A and W as suffixes. So therefore you can see there are two suffixes to indicate that sine I divided by sine R equals nu, but when light going from air to water, we write the nu as A nu W. The meaning is light going from air to water. If light is going from water to air, that is W nu A. That's it. The scientists that discovered this relationship of sine I and R, that angle of incidence and angle of refraction, is actually a young Dutch scientist, Snell. So therefore we call that is Snell's law after the scientist. So therefore the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. That is a law. That is what we call Snell's law. That is second law of refraction. We are talking about laws of refraction. The first law of refraction is, you know that basically a similar law has been learned in reflection. The angle of incidence, the angle of refraction, and normal drawn at the point of incidence lie on the same plane. You know that. I'm not going to talk about all these things, you know, right? So therefore, first law is really, really easy, and second law is the Snell's law. So this is what we call laws of refraction, two laws of refraction. They would ask you these two laws of refraction in examinations, therefore you have to learn them. Look at that. Light going from air to water, air to glass, so then we say A nu G, refractive index. And the light going from glass to air, so then G nu A. Light going from glass to water, so that is wrong, a done mistake. When light going from glass to water, that should be A G nu W. I have written A nu W, but G nu W.